Hi, welcome to Technical and Engineering Academy. This is Blessed Elvis. Linear first order differential equations are equations of the form where you have the first derivative added to a function of y, let's say in this case p of x of y, equated to a certain function, let's say q of x. So this is the standard of the linear first order differential equation. So whenever you have a function, or rather an equation of this form, then you have to use the linear first order differential equations rules. So how do we go about this one? So the first thing to do after you are done with identifying this is to write the integrating factor. So the integrating factor, let's say integrating factor represented by I, integrating factor is given by E with the power differential of p of x, then dx. So in this case then, after you have identified your p of x, you find your integrating factor as your second step. So your p of x will be here. So you will differentiate it. And then after you are done with differentiating this, I'm sure you are taking note of this, because for the sake of space, I might remove this. Okay, even if I don't. So after you find your integrating factor now, you go and replace it in the equation, the general equation. This is always the general equation that you will be using after you have differentiated this power here and then you have simplified. You always come to replace in the general equation where we have y equal to 1 over the integrating factor that you have found. Then inside here we have p of the integrating factor, that is I multiplied by q of x dx. So here we integrate, so there is an integral here, so integrate all these, then add it to a constant value c. So this is the general equation that you are going to be using, where you are going to be replacing the values. So in other books you will find that instead of writing the general equation as this, here the arrangement does not matter since we are multiplying. So g of x added to constant c. So in some books you find that they have written this instead. They have written it here because they have just multiplied y multiplied by the integrating factor. So in some books you find that they will write it like this instead, where you have the integral of the integrating factor multiplied by q of x gx added to constant c. So either this way or that way, it's just the same thing, it gives the same answer. So whatever equation you have been given, you first have to arrange it in the given manner, where you have gy over dx on this side, you add it to the function of p of x, where you have y, and then q of x here as the function. So this is the order in which it should be written. So let's look at some examples. So let's say you have, in this case, let's say you have 1 over x, y over gx added to 4y equal to 2. So in this case, as you can see, we have a function of y. We also have the first derivative here. So the first thing that we should do here is to write this in the standard form. So the standard form, remember, is what? Gy over dx added to p of x y equal to a certain function, let's say q of x. So this is the order in which it should be written. Now here we have what? 1 over x. So this 1 over x has to be gotten rid of. How? So we have to find a way in which we have to get rid of the 1 over x in front here, so that we just remain with gy over dx, because according to the rules, we just have to have gy over dx on this side. So how are we going to make it look like this? Oh no, I've just written the original expression instead of the given question. So the given question here we had 4y equated to 2. So the best way we can do is simply multiplying everything here with x. So let's do that. So here we multiply everything with x. Okay, so when we multiply with x, okay, let me just differentiate this with multiplication. When we multiply with x, this and this will cancel, so we are just going to have here gy over dx added to x multiplied by 4y. We are going to have 4xy equated to x multiplied by 2. We are going to have 2x. So in this case then, we have the differential equation of the order in standard form. So remember, our standard form was what? Gy over dx added to p of x of y equated to what? Q of x. So in this case, what is our p of x? So our p of x is what? According to this, y should just remain here since there is also y here. So we are just going to write our p of x as 4x. Then our q of x will be what? Okay, according to this, whatever values you have here are the functions of q of x. So in this case, we are going to have what? 2x. Okay, so this is how we identify the given expressions after you have written in standard form. Now, after you do that, we said the first step after you do that is to find the integrating factor. And remember that the integrating factor is where you have this standard here, e power of p of x dx. So in this case then, you integrate the power. So let's find the integrating factor in this case. So when we replace where there is p of x with what we have here, which is for x, we are going to have that. Okay, so we know that we can integrate. What is the integration of 4 of x? Okay, we know that writing like that, you can also write like where you write the constant outside the integral factor. So here we have x, then gx. Oh, sorry for that. Then gx here. Okay, so let's just wrap the top part here. Make sure that you take note of q of x. As q of x we have is what? It's 2 of x. It's 2x. So in this case then, we have this. So our integrating factor, let's just write it proper here. We have e raised to power 4 integral of x, then gx. So what is the integration of x? So according to the integrating rules, the integral of a variable, we know that here we have a power of 1. So you add 1 to the power, we have 2, and then divide the same power, we have 2 here. Okay, so in this case we can simplify this expression. We have integrating factor of x e raised to power. We know that these 2 can go into 4, where we have 2x squared. So in this case then, this is our integrating factor. We have this. So after you are done with finding the integrating factor, you go and replace in the general equation where we have, okay, let me just say where you have integrating factor of x equated to the integral of integrating factor multiplied by q of x gx added to a constant c. So in this case we have already found our integrating factor. What is our integrating factor? So our integrating factor was what? Was e raised to power 2 of x squared, okay, equal to our integrating factor was e. Okay, here we are integrating 2x squared multiplied by, if you remember, what was our q of x? Our q of x was 2x. So we write 2x gx here, then plus constant c. Okay, so that's how we go about this one. So in this case then, let's integrate this. How are we going to integrate this? So we are going to have ye raised to power 2x squared equated to. So here, integrating this, we know that we have 1 over 2 raised to power e 2x squared plus the constant c. So let me just write this properly. So we have y e raised to power 2x squared equal to 1 over 2 e raised to power 2x squared plus the constant c. So this is the general equation of the given question. So whenever you have been asked to find the general equation, you end here. So that's it. However, if you have been given particular conditions, let's say they say find the general equation where x, let's say x equal to 0, and then let's say y equal to 4. How can you go about this? So you simply replace these values in the given expression. So let's do that. So where there is y, we put 4, e 2. Where there is x, we put 0 squared equal to half e 2 0 squared added to constant c. So in this case then, we are looking for the value of the constant c. So here we know that when you, 0 raised to power 2, it's just 0. 0 multiplied by 2, it's just 0. So then we are going to have 4 power e, having 0 there, and then even here, as we have done here, even here it will be likewise. So we are going to have e power 0 plus constant c. So that's going to be our simplified expression for the given conditions. So let's find the value of c there. So what is the value of c? You may even go ahead and try that one. So in this case then, we know that n variable or number raised to power 0 is just 1. So there are 1 multiplied by 4 is just 4 here equal to, here, even here, this is just 1. So 1 multiplied by half, we're going to have half added to the constant c. So finding the value of constant c, we know that this half will come to the left side, and when it comes to the left side, it's going to be what? Negative. So in this case, then we're going to have 4. We subtract half, then here we remain with constant c. So in this case, then, this is the same as 4 over 1, because 1 into 4 is just 4. So for the sake of finding the fractions here we have constant c. So the common denominator, we know that the common denominator of 1 multiplied by 2, it's just 2. Then when we divide 1 into 2, we are going to have 2. Then 2 multiplied by 4 here as the numerator, we are going to have what? 8. Then subtract. Then 2 divided into 2 is what? It's 1. So 1 multiplied by 1, the power here, the power here, we are going to have, or rather the numerator, we are going to have 1. Okay, so in this case, let's create space. So we can simplify that one so that we may move at the same pace. So in this case then, what's 8 subtract 1? We are going to have 7. So we have 7 over 2 equal to constant c. So in the expression, the general equation that we had, if you remember, what was the general equation? If you are taking note of that, you simply replace where there is constant c with the value that you have found. Our equation was ye raised to power 2x squared equated to half e raised to power 2x squared, then plus constant c. So where there is constant c, you are going to replace with 7 over 2. So in this case, our general equation will become y e 2x squared equal to half e 2x squared plus 7 over 2. So this is our constant. So for the sake of just simplifying this, we can even factorize half, but all in all, this is the general solution. So let's look at the second example. Let's say you have been given dy over d theta equated to sec theta added to, theta added to y tan theta. So in this case, how would you write this in form of the standard equation where we have dy over dx plus p of x y equal to q of x? So always remember, whatever function has y should be here. Then dy over dx, or the differentiation, or rather the differential equation should be here. And then the remaining other values should be this side. Okay, so that's our body. So we can write the given equation in such a standard form. So in this case then, we already have the differential equation here. So we just have to take this to the other side since it's the one that has y. So in this case then, it's going to be dy over d theta. When this comes to the other side, you know it's going to be negative. If you don't want to write y in front here, you can as well say tan theta y, okay, equals to sec theta. So in this case then, what is our p of x? Rather, we are not using x in this case. We are using theta instead of x. So our p theta is going to be negative tan theta, and then our q of theta is what? Is sec theta. So we may go ahead and find the integrating factor. So in this case then, we have our p of theta equal to negative tan theta. So in this case, we know that our first step is to find the integrating factor. So how are we going to find the integrating factor? Remember, you always replace in this formula here, where we have the power of p. Okay, here instead of x, we should use theta. So here it's theta, and even here it's p of theta, g what? G theta. So in this case then, we know that our p of theta is negative tan theta. So in this case, let's replace with that value. So equals to e. Okay, so in this case, our p of x, or rather our p of theta is tan theta, then g theta. So we may go ahead and find the value for that. So what is the integration of tan theta? So the integration of tan theta itself is what? Is sec theta. But it is ln of sec theta. So, but we have a negative here. So it's going to be negative of ln sec theta. So in this case then, we are going to have negative ln sec theta. So make sure that you take note of the trigonometric integration values. When you integrate tan theta, you always get a ln of sec theta, or rather ln of sec whatever value you have there. So in this case then, we know that writing like this is the same as, okay, here, if we have a negative here, do you agree this is the same as we have 1 here? Because 1 does not affect anything. So if we have negative 1 or just negative ln, it's just the same thing. So I'm just writing this for the sake of what you are going to do next. So we have to simplify that as simple as we can. So writing like this is the same as saying ln of sec what? Sec theta raised to power negative 1. Is it okay? So if you don't want to add 1 here, you can also just say with power negative, it's just okay. Okay. But for the sake of just not being confused, you can just add a 1 here so that it might be simple for you. So in this case then, the integrating factor of this expression, so we know that when you have e raised to ln of something here, it's always equal to the things that you have after the ln. So what I mean is, for example, let's say you have e raised to power ln of x, so our answer here is x. Let's say you have a function ln x plus 1, so our answer here is what? X plus 1. So whatever value you have, provided that you have raised e to the power of ln, you always equate it to the value that you have after the ln function. Okay, so looking at this concept then, this is the same as saying just write in the sec theta raised to power -1. So this is the value. So whenever you have, so let me just, for the sake of just understanding, let me just remove, there was a lot of things there. So you have that. So always remember, let's say if you had, let's say e raised to power ln of, let's say x squared, what could be the value here then? It's x squared. So when you had e raised to power ln of, let's say you had x power 4, okay, power 4 minus 5. So what could be the value here? It's just x power 4 minus 5. So I hope that you now have the concept of whatever I have done there for me to have the sec of power 1. So simplifying this further, we know that when you have this is the same as theta here equal to, when you have that, this is the same as 1 over sec theta. Do you agree? Yeah, of course, it's the same. So in this case, what is 1 over sec theta? Okay, let's do this. We know that sec of anything, let's say in this case, sec theta is the same as 1 over cos theta, according to the integration, or rather the trigonometric rules. So sec theta is always 1 over cos. Okay, and then cosec theta is 1 over what? Sine. Then cot theta is 1 over tan. So make sure that you take note of those values. So in this case, we know that just this part sec theta is the same as 1 over cos theta. Okay, so in this case then, where we have sec theta in our expression here, we are going to replace with what? 1 over cos theta. So we are going to have 1 over cos theta, because 1 over cos theta that is down here is what? Is sec theta. So I'm doing this for the sake of simplifying the expression. Okay, so in this case we have integrating factor of 1 over cos theta. Now writing like this, we know it's the same as 1 divided by 1 over cos what? Cos theta. So in this case then, that is also the same as what? When you have such, according to fraction rules, that is the same as multiplication of the opposite side of the right party over 1 here. So when you cancel this and that, we are going to remain with what? Cos theta. So in this case then, it means that our integrating factor of theta rather is just cos theta. I hope that you have followed up to this far. So in this case then, our function for the integrating factor is just cos theta. So after we have found our integrating factor, according to the rules, we have to what? We have to then replace in the general equation where we have this equal to integrating factor multiplied by q of theta, then g theta here, plus the constant c. Okay, so let's do that. So here we have, what is our integrating factor? Our integrating factor is cos of theta equal to, even here we are going to replace that. So cos of theta, as we have here, multiplied by, now if you remember, what was our q value, or rather our function for q? So our function for q was sec theta. So in this case then g theta plus constant c, or rather, sorry for that, let's just get back. Okay, so in that case then, plus constant c, make sure that you add that. Okay, let me just write it on top here. So we have cos theta equal to cos theta, we are integrating this, multiplied by sec theta g theta plus constant c. So in this case then we have y cos theta equal to, so let's simplify. By now we know that sec theta is the same as 1 over cos theta, right? Okay, then g theta plus constant c. Okay, so in this case we have y cos theta equated to, we know that this and that are the same, so we can simply cancel them. So in this case, 1 multiplied by g theta is just the integral of what? G theta plus constant c. Okay, so in this case then, we can find the integrating, or rather we can integrate d theta, so that we simplify what's on the right part here. So in this case, remember we have this. So what is the integral of d theta? So plus constant c. So in this case then it's y cos theta equal to, what is the integral of d theta? So the integral of n function, or rather n differential equation you have here, it's just the value that is here. So in this case we have theta, so our value here will just be theta plus constant c. So this is the general equation of the given expression. So integrating, let's say if you are integrating dx, what would be the value? It's just x. When you're integrating dy, what is the value here? It's just y. So this is the point. So that's how we had this. So make sure that you take note of that rule, because it's going to help you in some other ways. So this is our value. This is our general equation. However, if you have also been given the particular conditions or the boundary conditions, you simply replace. So let's say you have been given y equals to 1 and also theta equals to 0. If you have these values, in this case you simply have to replace. Okay, so in this case then, let's say you have this as our general equation plus constant c, and then y is 1, then theta is 0. You simply replace. So where there is y, I will replace with 1, and then cos of 0 equal to 0 plus constant c. So in this case it's 1. What is cos of 0? So cos of 0 is just 1. Okay, then equal to, we know this is going to go out, so we are going to have c. So 1 multiplied by 1 is just 1 equal to c. So in this expression, where there is 1, you are going to write what? Rather, where there is c, you are going to write 1. So then our general equation will be y cos theta equal to theta. Our constant c value is 1. So this is the answer that you have. Thanks once again, guys, for staying this far. Please like, subscribe, share, and turn on the notification button so that you are updated whenever I upload a new video. Stay blessed.